Hi everyone, good morning. Is audio video both are clear, all of you? So somebody respond. Okay, I think it is visible now. Good afternoon everyone. So myself Rajendra Prasad, I am having 7 years of experience in GATE ESE and various state PSC coaching examinations. In total I am having 8 years of experience. Previously worked in ACE Academy, GATE Forum and other institutes, presently with An Academy. All of you know me from GATE Academy, ACE Academy and other institutes. These are all the subjects I'll be taking in An Academy Plus platform. This transportation was over, steel structures over, structural analysis over, surveying over. Now on 17th we'll be starting this RCC PSC. On 17th of this October month we can start this RCC PSC, right? Whenever anybody is subscribing for the plus courses, don't forget to use the code RP Civil. Okay, when you are using the code RP Civil, then you'll be getting 10% discount and other benefits. Okay, how are you all? Good afternoon. Somebody respond. So this is our faculty team, you can say. RP sir, KP sir, and AR sir, Abdul Rafi sir, Krishna Baka sir, and RP Rajendra Prasad sir, right? We three together will be teaching in English language in An Academy Plus platform, you can say. Okay. This is my contact number. If you are having any doubts or any inquiry regarding the Plus subscription, you can just contact me at this number. I'll be explaining you. Okay. Now, these are all the subjects taken by KP sir. Environmental, hydrology, irrigation, open channel flow, construction materials and management. These are all the subjects taken by myself, RP sir. Transportation, steel, structural analysis, surveying, RCC, PSC, engineering, design and drawing. Rafi sir will be taking only geotechnical. Except geotechnical, remaining all subjects are taken by KP sir and myself only. All of you, there is a price hike alert, right? Effective from this price hike is effective from what? This price hike is effective from which one? 20th. Which one? This price hike is effective from which one? 20th October. Okay. So if you are subscribing for the plus courses, if you are willing to subscribe for the plus courses, or any of your juniors are willing to subscribe for the plus courses, please inform them so that they will be subscribing as early as possible, right? So that they will be subscribing as early as possible, right? Like that. And any doubts, contact me at that number. And whenever you are subscribing, your juniors are subscribing, please don't forget to use this code RP Civil as the referral code for getting 10% discount. Okay. Now, these are the courses, plus courses I have started. That is a complete course on transportation engineering. That was already done. Okay. Complete course on the structural analysis was already completed. The complete course on airport engineering also was done. Complete course on plastic analysis was done. Steel structures was over. Next, complete course on this plastic structural analysis was also over. Surveying, it was just got over by today. Actually, in that field astronomy part was not discussed, except that remaining everything was covered. So in today and tomorrow's special classes, I will be covering that field astronomy. Okay, there will be a crash course on transportation engineering starting from 21st November to 10th December. And complete course on reinforced concrete structures I will be starting from 17th October to 17th November. The class timings will be every day from 5:30 p.m. to 7:30 p.m. 5:30 p.m. to 7:30 p.m. every day you are having, right? So how many are willing to subscribe for the plus courses? How many are? Okay, when you come to this reinforced concrete structures complete course, the details of the course are like this: 17th October to 17th November it will go up to. Every day 5:30 p.m. to 7:30 p.m. classes. These are all the topics you are having. I'll be discussing about these topics, right? The masonry structures and earthquake resistant design structures will not be discussed here. For that, either we'll plan a separate short course or we'll plan in marathon sessions, right? Whatever it is. So whenever you are subscribing using the code RP Civil, these are all the advantages you'll be getting. Okay. That's today's which one? 15th, na? 15/10/2020, the 12 p.m. You are having which one? MSQs on RCC. Okay. Next again on 17th. Same 12 p.m. only. We are having which one? MSQs on which one? PSC, pre-stressed concrete structures. Again. It's 19th. On which one? That MSQs on which one? Highway. Okay. Again on 21st. Same time. MSQs on which one? Railway. Annadurai. Hi. 23rd. This MSQs on which one? Airport I'll be taking. Okay. These are all your YouTube classes, right? These are all your which one? YouTube classes you can say. And special classes, if you just observe today, what is the date today? 15th, na? 15/10/2020 at 8 p.m. We are having that field astronomy part 1. Field astronomy 1. And on 16/10/2020, same timing, 8 p.m. field astronomy part 2, right? Again, one more important thing, on 18th, if you just observe, right? On 17th, you are having YouTube class. On 18th, if you just observe, at 2 o'clock, we are having which one? Live interaction. Live interaction session. Session with which one? Bark scientist. And All India GATE rank 72 he has got, right? He is actually my own brother only. We'll be having live interaction session with this fellow, my brother, that is Bark scientist and All India ranker 72 on 18th at 2 o'clock, right? 18th, that is Sunday at 2 p.m., right? Please share the information to all your friends so that they will also be getting benefit from this session, right? These are all the sessions you are having, right? What are these sessions if you just observe? These are your which one? These 3 sessions are your which one? Unacademy learning app. These are on the Unacademy learning app, right? All of you are having Unacademy app? All of you are having Unacademy app? If you are not having Unacademy learning app, in the description you can find that Unacademy learning app. You download that Unacademy learning app and follow me just by searching with RP Civil. Then you can find my profile. When you follow me, you can get all the details of the classes, plus classes, free classes I am going to take. Okay, like that. Now, again I am telling you, there is a price hike alert. There is a price hike possibility. So whenever you are willing to subscribe for the plus courses, subscribe as early as possible so that you will not be paying much money, right? More money. Okay. Now, coming to this class, MSQs on reinforced concrete structures. MSQs on which one? That reinforced concrete structures you can say, right? What is the meaning of this MSQ? Tell me, anyone? Anyone having any idea about MSQ? Anyone having any idea about MSQ? Multiple selection questions. Anybody having any idea about MSQ? Multiple selection questions. Anyone? It means what? More than one answer. right? More than one answer is which one? Correct. What is the meaning of this MSQ? You can say more than one answer is which one? Correct. You can say, right? More than one answer is what? Correct. You can say, right? More than one answer will be correct. You can say, right? If it is more than one answer, which one you have to select, obviously. No. Yes, Ravi be correct, right? Multiple selection questions means what? Multiple answers, right? Among the given 4 options, there may be 2 options correct or 3 options correct. Like that you may be having, right? MCQ means what? What is the meaning of MCQ? MCQ means only, just observe that MCQ means what? Only one option is correct, right? Only one option is correct. MSQ means what? More than one option is correct, right? More than one option are correct. Like that. So that is a basic difference between MCQ and MSQ you are having, right? Just for an example, first question, if you just observe, which of the following, yes, correct. Which of the following will be used on RCS we are solving now? Which of the following will be used for calculation of elastic modulus of concrete? Which of the options we are using? If you just observe, the first option I will be writing here. If you just observe it, what is it? First option you can say. It would have been much better if you take ESE PVQs with a detailed explanation. No, actually I have planned these other sessions only, that engineering mechanics sections, but the administrative people said that you have to start these MSQs. I have to take, right? I have to follow their instructions actually, right? I cannot take a decision on my own. Sachin, yes, you are correct only, but we'll do that in other classes otherwise, right? These 5 classes must be MSQ classes only, right? They have instructed us to give questions on these MSQs only, okay? MSQ questions only they are asking us to do for this month, right? For me especially, right? So that is why I'm planning this. Otherwise we could have done with other one, okay? Don't worry, we'll do them in the special classes, right? We'll be doing it in them in the special classes, you can say, no problem, because the heading is MSQ now, so we have to look at MSQs only, right? So previously in the GATE and ESE there were no MSQ. There were no MSQs previously you were having, and recently only you are having these MSQs, you can say, right? Like that. Now here if you just observe, option A 5000 root FCK, it is 5000 root FCK. Option B, that EC equal to which one? 5000 root FCK divided by which one? 5000 root FCK divided by which one? 1 plus theta. Option C is what? 5000 FCK. Option D is what? 5700 root FCK. Now tell me which options are correct. Tell me. Which options are correct? Tell me now. Anyone tell me which options are correct? I'll just wait for your answer, because actually there is a lagging of 10 seconds or 5 seconds like that. Which options are correct? Tell me now among all of them. Somebody tell me which options are correct. Which options are correct? Somebody. A is correct. Yes, A is correct, Ravi. 5000 root FCK according to the new code. That is fine. And what is one more option correct? Yes, A is a long term, A is a short term elastic modulus, B is your which one? Long term elastic modulus. A is your short term elastic modulus and option B is your long term elastic modulus. And D, if you just observe, yes, D is as per which one? Old code we are telling it or not? Yes, Aineri Ram Prasad Gaud correct, right? Yes, right? Sagar correct, right? Ravi correct, Gaurav correct, all of you. So it is as per the old code, but we need to consider this now, or we should not consider this now. D is as per the old code means as per old code we have to consider now, or we should not consider as per old code now. Tell me all of you. As per old code we have to consider now, or we should not consider as per old code now. Manu Chaudhary, hello. How are you? So we need to consider the old code, or we should not consider the old code now? We shouldn't consider the old code now. Yes or no? We shouldn't consider the old code, right? We shouldn't consider the old code now, right? Because it is as per the old code, right? It is as per the old code, you can say, right? Now, so which one are the answers now? Correct answers? Option A is correct and option B is correct, right? A is corresponding to which one? Short term. So because in the question, nothing is mentioned. Short term is not mentioned and long term is not mentioned. So we have to consider both. Both are correct now. Like that, your MSQs will be there. Okay? Like that, the basic MSQ. This is your basic MSQ. Like that, we are having the basic MSQs, you can say, right? Like that. Now, second question, you can say. Second question, if you just observe. So here, what are this second question, you can say? So here, if you just observe. Now, here if you just observe, a concrete mix is prepared. Okay, a concrete mix is which one? Prepared and tested. And tested for which one? A concrete mix is prepared and tested for which one? Tested for which one? Compressive strength. Compressive strength, right? So now which of the following are correct, right? Which of the following statements are correct, right? Identify correct statement or statements. Okay, so first one is what? What are the different elements we are using for testing the compressive strength? Tell me. What are the different types of specimens we are using for testing the compressive strength? Tell me, all of you. What are the different elements we are using? Tell me. So FCK, let us say, right? FCK by means of which one? FCK by means of which one? Cylinder of size 300 by 150 will be greater than or equal to which one? FCK obtained by means of which one? Cube of which one? 150 by 150. That is the first option, you can say. Yes, cube and cylinder, right? Civil 17112 and go with correct, right? And option B is what? FCK cylinder of 300 by 150 is lesser than which one? FCK cube 150 by 150 size, you can say. And option C is what? FCK cylinder is which one? Approximately FCK cylinder is approximately which one? 0.8 times which one? FCK of which one? Cube of same dimension, right? 150 by 150. This is 300 by which one? 150 standard size. Now, option D. All are correct. Now tell me which option is correct. Yes, Govind, Ravi, Ankit, all of you correct. Can you tell me which option is correct? Which options are correct now? I'm just erasing this one. Which options are correct? Yes. Which options are correct? Tell me. Which options are correct? Yes, right. Sagar and Govind said B and C are correct. Others, what do you say? Others, what do you say? Here, if you just observe these two, right? So now approximately the cylindrical strength will be approximately equal to which one? 80% of the cube strength, right? For the same mix, yes, civil 17 also correct. For the same concrete mix, right? For the same concrete mix, right? A concrete mix means same concrete mix, right? For the same concrete mix, if you just observe, right? For the same concrete mix, if you just observe, cylindrical strength will be lesser and cube strength will be higher, right? So that is second option is satisfying that, right? Third option is also satisfying the same thing or not? Cylindrical strength equal to approximately which one? 0.85 times 0.8 times which one? Cube strength, right? 0.8 times cube strength, right? Means that is also satisfying what? That is also satisfying what? Which one? Both options are same only, obviously or not? Yes. Why it is like that? Yes, as Ankit said, cube strength is more than the cylinder because of the frictional stresses. If you just observe, when you are testing the cube, you are testing the cube in this manner. We are testing the cube in this manner over this area, yes na? And when you are testing the cylinder, what will happen? We'll be testing the cylinder along the length of the cylinder in this manner, right? We'll be testing the cylinder along which one? Along the length of the cylinder like this. And tell me, when you are testing like this, one reason is what? Who is having more slenderness ratio? Tell me. Anybody tell me who is having more slenderness ratio? The cylinder is having the more slenderness ratio, no? Yes or no? There is no steel, right? There is no steel, Govind, actually. There is no steel actually in that. Okay, steel restraining effect. Okay. So here, what you are having? Who is having more slenderness ratio? Tell me, anyone? Cube is having more slenderness ratio or cylinder is having more slenderness ratio? Cylinder is having more slenderness ratio, right? When cylinder is having more slenderness ratio, yes, that's right. When slenderness ratio is more, right? When slenderness ratio is more for the cylinder, what will happen here? When slenderness ratio is more here, more in cylinder, what will happen? It will be subjected to the buckling effect also or not? It will be subjected to the buckling effect also. Whenever there is a buckling strength, whenever there is a buckling failure possible, its compressive strength will be decreased automatically or not? Yes. Yeah, the steel plates only we are using it. At the top, we are using the steel plates only. That is fine. First, let me complete this point. So, obviously, what will happen? You will be getting lesser strength for this cylinder, obviously, compared to the cube strength or not? Is that point clear, all of you know? Because of this slenderness ratio, because of this slenderness effect, what will happen? Because of this slenderness effect, what will happen? Buckling effect will be there. Buckling effect will will reduce the compressive yield strength, compressive strength, right? Direct axial compression test strength. So that is one reason, right? That is one reason. And the second one, yes, as you said, steel restraining effect is more in cube than cylinder. Why that steel restraining effect is higher in cube than cylinder? If you just observe, you are transferring the same load only now. Here, if you just observe, more area is available, right? Okay. I'm not Swami Sir Medici. Okay. Swami Gupta sir, you are talking about? Okay. Here, who will be having more contact area with respect to that? Who will be having this more contact, you can say, if you just observe? The dimensions, in all the dimensions, it is, if you just observe, this is your 150, 150, which one? This is your cube, so this is your cube, and this is your cylinder, you can say. Right, with the same dimensions, right, with the same dimensions, you can say, right, everywhere it will be same dimensions. Now here, if you just observe, what is the difference you are having? More area you are having for this, which one? More restraining effect is there for cube now. So at the top, more restraining or resistance area is there for cube. So obviously it will be resisting more load, obviously, or not? It will be resisting more load, obviously, right? As you said, right? This buckling effect is one thing. So especially in the RCC, right? Especially in the RCC, the size and shape effect is also very, 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 very important. Now, when you are using FCK, compressive strength, we are getting it as FCK, but do we design for FCK? Anybody? Do we design for FCK, or will be designing for lesser than FCK? Will be designing for lesser than FCK, no? Will be designing for lesser than FCK. How much lesser? 2/3 of FCK only will be designing, right? Why? Why we are designing this 2/3 of FCK? 2/3 of FCK is nothing but 0.67 FCK. Why we are designing only for 0.67 FCK? Tell me. 0.67 FCK, only the strength of concrete we are assuming. Why? Why not FCK? Because if you just observe, this FCK will be obtained for 150 by 150 by 150 cube, but in practical, yes, no, but in practical what you are having? But in practical what you are having? The concrete will be of different dimensions, right? Concrete will be of different dimensions and different shapes. Then you consider those different dimensions and different shape effect, the strength will be decreasing automatically. How much reduction will occur? 1/3 of reduction will occur up to the 400 mm size, right? Yes or no? Up to the 400 mm size, there will be 1/3 decrease we are having, right? So it is, yeah, loses in practical, yes, correct, right? Shape and size factor. It is not load factor. It is shape and size factor, right? It is shape and size factor going. Now, so based on the shape effect and size effect, we are considering this 0.61. But we need to apply the partial safety factor for this one also or not? How much is the partial safety factor for this we are applying? How much is the partial safety factor we are applying for this? If you just observe. For bending it is different, right? For bending it is different. For bending it is different. For bending it is different, and that for bending we are applying which one? That 1.85, right? Yes. Each sample is different. Yes, each sample is different, and that size, whenever size is increasing, strength will be decreasing. Whenever shape is changing, the strength is changing. All parameters are there, right? Like that. And when you are applying this partial safety factor, gamma for material strength, then you will be getting which one? That design compressive strength, right? Design compressive strength. 1.15 is for which one? Govind. 1.15 is for which one? Steel. Govind. 1.15 is for steel, but this is for concrete, right? For concrete, how much it will be? 1.85 or 1.86, you can say. And we'll be designing for which one? 0.36 Fy, like that you are designing, or sorry, it is not 1.8, it is 1. How much you can say? You will be designing for which one? You will be designing for this. You will be designing for which one? Do you remember? For which value we are designing for? Yes, 1.15 for steel, 1.15 for steel. And if we just observe 0.67, do you remember, all of you? So we are designing for which one? This 1.5 actually, right? Not 1.87. 1.85 is for different one, you can say. 1.5, right? That is partial safety factor for material strength. When you are doing it, what it will become? 0.446 Fy it will become, or not? 0.446 is nothing but which one? 0.45 FCK, not FI. 0.45 FCK we are designing for or not? Yes, right? We are designing for it. 1.15 is for which one? Steel. 1.5 is for which one? Concrete. That is a partial safety factor for material strength. Okay? Is that clear now? The shape effect and size effect will come into picture. The shape effect and size effect will come into picture. That is the reason we are not designing for FCK. We are designing for 0.6. We are considering the strength of concrete under any shape, any size as 0.6 FCK. For that again we are applying partial safety factor 1.5. Then it will become 0.45 FCK, right? So is that point clear, all of you now? All of you, is this point clear? Is this point clear, all of you now? If it is clear, I'll move on to the next question. Is the point clear? Somebody respond. Sir, no. Hello. Nobody is responding. Okay, let it be, right. That 0.67 FCK, that 0.67 FCK, how it has come? The 0.67 FCK has come from which one? Yeah, now I think there is a lot of delay we are having. Okay, let it be. There is a lot of delay we are having, I think so. Okay, let it be. Now, okay, right. So we'll be proceeding to the next question, right? We'll be proceeding to which one? The next question, you can say, right? So what is this question? Shall we move on to this numerical question, all of you now? Shall we move on to this numerical question, all of you now? Shall we just solve a numerical question here, right? We'll just solve a numerical question here. Now, here if we just observe a beam. Okay, there is a lag. Okay. A reinforced concrete beam of which one? 400 by 500 effective. 400 by 500 effective means what? What is that 500 depth you have to consider? 500 depth is the effective depth we have to consider, right? 400 by 500 mm effective means what? This 550 mm, 500 mm is effective depth, right? Effective is provided with which one? Is provided with M25 and Fe415 materials having which one? Having which one? First one, 3 number of 16 mm dia bars. 3 number of which one? 16 mm diameter bars, right? Having which one? 3 number of 16 mm bars, you can say, right? 16 mm bars, you can say. So let us say effective cover. What is that? Effective cover equal to 50 mm, you can say. And which of the following statements are correct now, right? I'm just writing the options, you can say. First option. It is an under reinforced section. Use working stress method, you can say, right? Use working stress method, right? It is an under reinforced section, option A. Option B is what? Depth of neutral axis equal to which one? 120 mm approximately. And option C is what? Moment of resistance. Moment of resistance equal to which one? 71 kilonewton meter. Option D is what? It is an over reinforced section. It is an over reinforced section, right? Like that you are having, right? These are the options you can say, right? These are the options you can say, right? Somebody tell me which options are correct. Somebody tell me here which options may be correct here, which options can be correct here. So let us take that sigma CBC equal to 8.5 MPa, and also you take it as which one? Sigma ST equal to that 230 MPa, you can take it. Okay, these are the things you take it. Sigma CBC equal to sigma CBC means permissible stress in concrete in bending compression is 8.5 MPa. Sigma ST means what? Permissible stress in steel in tension is which one? 230 MPa, you can say. No. Anybody? Somebody calculate? Which options are correct now? Under reinforced section, Govin, you are telling. Other option, under reinforced section, okay, you are telling. Second option, other options, which other options are correct now? Okay, use LSM, use working stress method. Okay, use working stress method. Okay, let it be. We'll be solving this question because here what is that given? If you just observe, this is the bar rectangular section of beam given. 3 number of which one? 16 mm diameter bars. Up to this, the depth will be, effective depth will be 500 mm. What is it? 500 mm, small d. This is width is which one? 400 mm, you can say. This is equal to which one? Small b, you can say. Right? What is that? FCK given? FCK equal to 25 and FY equal to which one? 415, like that. So what is that? AST, you can say, get it now. How many are there? 3 number of which one? 16 mm dia bars or not? 3 number of which one? 16 mm dia bars you are having or not? Yes. What is that AST? You can say 3 into pi by 4 into which one? D square, 16 square. So, what is that AST you are getting now? Area of steel, how much you are getting now? Area of steel, how much you are getting now? 603 point which one? 603.19 millimeter square, right? 603 point which one? 19 millimeter square, right? This is the AST you are getting, right? And what is that M? You can say modular ratio. When it is a working stress method means what? What is that modular ratio is important or not? What is that modular ratio? You can say 280 divided by 3 sigma CBC. What is that? 280 divided by 3 into what is that? Sigma CBC, permissible stress in bending compression is given 8.5 MPa. Yes, correct, right? Going correct. 8.5 MPa. Then what is the modular ratio if you just observe? What is the modular ratio if you just observe? 10.98, right? The modular ratio will be which one? 10.98, right? 10 point which one? 98, right? 10.98 you can say. Now, how can you calculate this neutral axis? How can you calculate this neutral axis if you just observe? For neutral axis, that compressive force equal to tensile force. Now, what is that compressive force? You can say B into N by 2. Let us say this N will be the neutral axis depth if you just observe. This N is your neutral axis depth, and what is this one you can say? D minus N. Okay. Yes, B into N by 2 equal to which one? M into AST into D minus N. Is it not? For neutral axis, compressive force equal to tensile force. What you are doing? Compressive force is which one? B into N by 2 equal to M into AST, right? How it has come actually if you just observe? This is B you can say. This is N you can say. This is your neutral axis you can say. And this is which one? D minus N you can say. So what is that? Moment of area of moment of compression area about the neutral axis equal to moment of tension area about the neutral axis, right? What is this compression area? What is the tension area? You can see if you just observe, we are converting that into which one? Equivalent section, equivalent concrete section. When it is an equivalent concrete section, concrete in the tension region will be deleted. This is your N you can say. This is your B you can say. And this is, what is this area? M into AST, right? If area of steel you wanted to replace, if area of steel AST you wanted to replace, you have to provide which one? M into AST amount of concrete you have to provide, right? What is this distance then? This is D minus N. Now, what is it? First moment of the compression area about neutral axis equal to first moment of the tension area about neutral axis. That is how we are getting, right? You can observe my special classes on this single reinforced method, if you can remember, right? B into N by 2 is the first moment of area of which one? Compression area equal to M into AST is the tensile area into what is the distance from neutral axis? D minus N, right? From this you are getting here, right? From this you are getting here, right? You just substitute these things. B is what? 400 into N square divided by 2 equal to M is what? 10.98 or 11 into AST is what? 603.19 into D minus N, right? What is the D minus N you can say? What is the D minus N you can say? 500 minus N. Tell me what is that N value from here? Somebody calculate what is that N value from here? Yeah, actually there is some problem. This 550, right? For 550 these are valid actually. Just take this as 550 only. Yes, just take this as 550 only. When you take this 550, I think you will be getting the correct answer, right? 550. Just take it 550 and do it. Civil engineering subjects 128.66. Okay, that is fine. You just substitute 550 and do it. For 550 effective depth, how much you are getting? Tell me. For 550 effective depth, how much is that you are getting, all of you know? And equal to how much, all of you? I think there is a lot of lagging here. How much? Somebody tell me. $119.41. Yes, Govind. N equal to 119.41 mm. And we need to identify whether it is under reinforced section or over reinforced section or not. How can you identify under reinforced section or over reinforced section? If you just observe, N balanced we have to calculate or not. Neutral axis depth for balanced, how can you calculate this? J balanced into D. What is that J balanced? You can say now. J balanced you can say now. If you remember, how can you get this? M sigma CBC by M sigma CBC plus sigma ST. Yes sir, no? Into D na. Yes sir, no? What is that? M sigma CBC? 10.98 into sigma CBC is what? What is that sigma CBC? You can say 8.5 divided by 10.98 into 8.5 plus sigma ST is what? 230 into what is it? Effective depth you can say no? 550. Tell me what is that N balanced? Neutral axis depth corresponding to balanced section is how much? Neutral axis depth corresponding to balanced section is equal to how much? How much is that N balance you are getting all of you now? How much is that N balance you are getting now, all of you? Anyone? Nobody calculated? Okay. It would be, how much it will be? 158 point which one? 76 mm, right? 158.76 mm, right? Yes, correct, Govind. Since N is lesser than N balanced, it is an under reinforced section or over reinforced section. Neutral axis, actual neutral axis is lesser than the actual neutral axis is lesser than the balanced neutral axis, means it is under reinforced section or over reinforced section. It is obviously the under reinforced section. No? When it is under reinforced section means the first option can be correct and this option D is wrong. Whenever it is under reinforced section means under reinforced section means what? Reinforcement is lesser than the balanced section. Concrete is which one? Higher than, equal to the balanced section or higher than the balanced section, means concrete will be stronger, reinforcement is weaker, right? So therefore moment of resistance must be with respect to reinforcement only we have to take advantage, because who is going to fail first? Under reinforced. Under reinforced means you did not provide the reinforcement to the required value. You did not provide reinforcement to the required value means reinforcement will fail first, right? With respect to which one we have to use? With respect to steel only we have to calculate, right? Sigma ST into AST into which one? D minus N by 3. That is what. What is that sigma ST? 230 into what is that AST? 603.19 into D. What is that D? 550 minus what is that N by 3 you can say? Neutral axis is what? 119.1. 119 point which one? 41 divided by 3 into 10 power minus 6, because you want it in kilonewtons, no? Kilonewton meter, no? What is the moment of resistance you are getting? How many kilonewton meter you are getting? You just observe how many kilonewton meter you are getting for this. Somebody calculate this and tell me. How much it is? Yes, 70 point which one? 78. So which option is correct? So this neutral axis depth is 120 mm approximately correct, and moment of resistance 71 kN approximately correct or not? So what is your answer for this question? A, B and C, all the three options are correct or not? For this question, how many options are correct now? All the three options will be correct for this question or not? Yes. A, B and C, all the three options will be correct. You can say, right? All the three options can be correct. You can say, right? Like that. This is your third question, you can say. Now, question number 4. Just observe. Identify which one? Correct answer. How can you identify this correct answer? Epsilon ultimate equal to which one? 0.2 percentage for which one? Direct compression. Correct answer regarding concrete. So means ultimate strain equal to 0.2% in case of this direct compression. That ultimate strain equal to 0.35 percentage in which one? Bending and compression is equal to bending compression, you can say, is equal to bending compression, you can say, and epsilon ultimate equal to which one? 0.33 FCK divided by E of concrete for direct compression, or you can take it as which one? Epsilon ultimate equal to which one? 0.45 FCK divided by EC for bending compression. Tell me which options are correct now? Tell me which options are correct, all of you now? Which options are correct? Somebody tell me which options are correct now? So in case of this direct compression, 0.2% is the ultimate strain taken for designs. Okay, that is first one is correct. In case of bending compression, 0.35% is taken as a bending compressive strain, right? Bending compressive strain, you can say, right? Now, so we don't calculate the ultimate strain from here, right? We don't calculate ultimate strain from here, right? We don't calculate which one? Ultimate strain from here, right? Like that. Which option? Is it okay now, all of you? Yes, I think it is okay now, right? I think that new number is visible. Okay, it is okay now. Yes. So this next question, let us say, D beams or sorry, what you can say, beams are said to be D beams. D beams design is used if which one? Under which condition, you can say? First one, if L by D, right, that span divided by the total span divided by which one? L is span, D is the total depth. It is lesser than 2 For simply supported beams, L by D will be which one? For which one? Simply supported beams. See, L by D ratio is which one? Lesser than 2.5 for continuous beams, and L by D is lesser than 2.5 for which one? That is 2. This is 2.5, right? Okay. This is 2.0. That is 2.5, right? For continuous beams. Tell me which options are correct among them. Instead of designing them as a normal beam, we will be designing them as which one? D beams. When will be designing the beams as a D beams? When will be designing the beams as a D beams? Tell me. Options are correct, all of you. Which options are correct, all of you now? Select. Which options are correct, all of you? Which options? I think which options? Anyone? Anyone tell me the answer? Yes, right. This A. When L by D is right, when the length or span by depth is lesser than 2 for simply supported beam, and L by D is lesser than 2.5 for continuous beam, right? For which one? Continuous beams, you can say, right? Continuous beams, you can say, right? So this is wrong, this is wrong, right? Which options are correct now? Option A is correct and option D are correct, right? It is A and D. For simply supported beam, it is lesser than 2. For simply supported beams, L by D is lesser than 2 for simply supported D beam. If L by D is lesser than 2.5 for continuous, 2.5 for continuous, then only you can design it as D beam for continuous beam. Okay, you have to be careful. A and D are correct, right? Not A and C. Okay, you have to be careful. A and D are correct, right? A and D are correct, right? Not this A and C. You have to be careful. Okay. No. Next. Okay. Now, question number 6. If you just observe, what is this question number 6? You can say. So is that clear? That question, previous question, all of you know. Is this clear? Yes or no? Is this clear, all of you? Okay, let it be. Right here. No. Which of the following that is 2, right? C and D options. That is 2. I have changed it now. I have changed it to 2 now. Govind, I have changed it to 2, right? 2.5 I have strike it off and I have changed it to 2 now. I have changed it to 2, right? Yes, now. I have changed it to 2. I have strike it off and I have changed it to 2 now. That is what you have to observe. Okay. Right. Which of the following are related to limit state of serviceability? So which one are related to this limit state of serviceability? If you just observe, cracking. Second one, overturning. Third one is what? sliding shear tell me which one are related to limit state of serviceability here, all of you? Which one are related to limit state of serviceability now, all of you? Which one? All of limit state of strength will be there and limit state of serviceability will be there. It's not both. The limit state of strength will be there and limit state of serviceability will be there. Limit state of strength and limit state of serviceability both are there. Here, which one is limit state of strength and which one is limit state of serviceability? Cracking is the limit state of serviceability in a state of what? Overturning is limit state of strength only as civil engineering, correct, right? Sliding is also limit state of strength only. Shear is also limit state of strength only. Deflection is a limit state of serviceability, right? So what are the options you can say? A and E are the options or not? Yes, A and E are the options you can say, right? Like that you are having, right? Now, civil engineering subjects and Govind, you answered correctly. Now, which question we have completed? We'll see 10 questions and we'll leave. It's question number 7. You can say, right? Question number 7 you can say. What is it? Question number 7 you can say here if you just observe. Now here, identify correct statements for under reinforced section, right? What is that? URS you can say. URS is nothing but your under reinforced section, right? Under reinforced section. What is that? For limit state method, that XU is lesser than which one? XU limiting. But not for working stress method, okay? Or for working stress method, that N is lesser than N balanced you can say, but not for limit state method. Now, third one is what? Moment of resistance is lesser than which one? MU balanced in case of this limit state method. And what is that? Steel fails first, then concrete. Concrete fails first than steel. Like that. So tell me which option is correct now, all of you? Which options? I think third option only there you are in. Which options are correct, all of you? Which options are correct now? Here if you just observe, A is wrong, right? Either it is a limit state method or working stress method. XU will be lesser than XU limit compulsorily, right? For working stress method and limit state method, for both the neutral axis should be lesser than that, right? Moment of resistance is lesser than MU balanced for limit state method. Yes, correct. C is correct, right? D, because it is under reinforced section, right? Because it is under reinforced section, reinforcement is not up to the mark, na? Reinforcement is not up to the mark. So who will fail first? Steel fails first, then concrete, right? Concrete will not fail, right? Which one are correct? C and D. Govind, you are correct, right? Govind, C and D are correct, right? C and D are correct. Okay, C and D are only correct, you can say. Next, question number 8. Okay, is that clear why C and D is correct, all of you? Is that clear why C and D is correct, all of you now? Yes or no? Yes or no? Okay, it should be. Now here, what you will do? Which statements are which one true, you can say, right? Which statements are which one true, you can say, right? Which statements are true among the given statements, right? First statement, if we just observe, what is this first statement, you can say? The first statement is like this, you can say here. Okay, if you just observe, in limit state method and working stress method, in limit state method and working stress method, plane sections before bending, plane sections before bending, right? Plane sections before bending, right? Which one? Plane sections before bending remains plane after bending also. Plane sections before bending remains plane. Which one? After bending remains plane after which one? Bending, you can say. Now the second one, tensile strength of concrete is ignored in LSM and WSM. Now third statement, tensile strength of concrete, tensile strength of concrete is considered in which one? Is considered in limit state method. Option D is what? Tensile strength of concrete is considered in working stress method. Tell me which options are correct, all of you? Tell me which options are correct, all of you now? Tell me which options are correct, all of you now? Which one is correct, all of you? Which options are correct? Which one? What is sorting? A, B and C. Okay. If you just observe limit state method and working stress method, whatever the method you are considering, plane sections, yes, Abhijit, Govind, correct, right? Plane sections before bending remains plane only after bending. That is resulting in which one? Strain variation is linear or not? This point only will result in which one? Strain variation is linear. Tensile strength of concrete is ignored in limit state method and working stress method. Yes, both the limit state method and working stress method, we are ignoring the tensile strength of concrete. So obviously this option C and D also wrong or not? Obviously this option C and D will become wrong, you can say. Option C and D will become wrong, you can say, right? Like that. Now just observe. Okay, we'll just go for these two more questions. 8th question, 9, 10, right? If you just look at these two questions, it will be over, right? We'll close the session, let us say. So now, with respect to this, in limit state design, LSD means what? Limit state method of design. Limit state design, the stress distribution, limit state design, identify the correct limit state design. What you will be identifying? Them statements. The statements you have to identify. The following statements is correct. Limit state design. First one is what? Strain and stress variations are linear. Only strain variation is which one? Linear. Option C. Stress variation is non-linear. Stress variation is which one? Non-linear. Strain variation is which one? Non-linear. Tell me which are correct now. Which are correct for this question? Tell me now. Which options are correct? Tell me all of you. We just observe stress strain variations are linear. No. This is your strain variation. If you just observe, this is your strain variation. And what is the stress variation? If you just observe, this is the stress variation you are having on it. So this is your stress variation 0.45 FCK you are having na? Yes, no? Like that. So first option is wrong. You can say that first option is wrong. Only strain variation is linear. Yes, correct. Stress variation is non-linear. This is your stress variation, you can say. Strain variation is non-linear. Strain variation is obviously linear, you can say, right? Like that, right? All of you correct. Govind, the civil engineer, Ringa and Abhijit, all of you correct like this. Okay. Now, question number 10. Let us see. So here actually where stress and strain variations are linear, tell me, all of you. Where your stress and strain variations both are linear? Where stress and strain variations both are linear, tell me all of you. Tell me anyone when both stress and strain variations are linear. When the stress and strain variations are linear, in working stress method na, in case of this working stress method, stress and strain both variations are linear, you can say, right? Stress and strain both variations are linear in working stress method, but in the limit state method, strain is only having linear variation, stress is having the non-linear variation, you can say, right? You have to be careful, right? That question, doubly reinforced sections doubly reinforced, which one? Rectangular sections beam. Design beam sections, yes, Govind, correct, right? Are designed under the following condition. Under the following instances, right? What are these following instances, you can say? First instance, okay, tunnel and take classes on tunnel and airport. Airport plus classes already have taken the subject, airport plus class already over. One class on YouTube also have taken that airport classification number, payment classification number. That tunnel part I did not take. Okay, let it be. We'll be taking in tunnel part. Okay, no problem. Abhijit, yes, it is working stress, not the plastic. Okay, beam. Beam subjected to which one? Reversal of stresses. Depth is restricted. Next one. Members or beams subjected to which one? Impact. Next one. Okay, special class you want me to take? Okay, we'll see. They will be acting like which one? Supports of these continuous beams. Next one. Always designed. Okay, tell me which options are correct now, all of you. I'll be just waiting. I think in your it is at the third one only. Option C only it is there. Beams subjected to reversal of stresses, right? Beams subjected to reversal of stresses means compression will become tension and tension will become compression. That is correct or not? First option, all of you. Beams subjected to reversal of stresses means compression will become tension, tension will become compression, right? That is A is correct, right? When depth is restricted, yes, correct, right? Depth is restricted, right? Now what we need to do? Always designed. We will be designing the doubly reinforced sections always or not? We'll be designing the doubly reinforced sections always or not? We don't design the doubly reinforced sections always, right? And again, what about the middle 2 points? Member subjected to impact and supports of continuous beams. When? Tell me, correct or not? When you have to go for? When you have to go for it, members subjected to impact, right? When members are subjected to impact, what will happen? That impact load is nothing but your dynamic load now. Impact load is nothing but your dynamic load. That dynamic load, whenever the dynamic load is there, it is better we should have ductile behavior or brittle behavior. Tell me, which one is better? It is better we should have ductile behavior or it is better we should have brittle behavior? It is better we should have ductile behavior. Now, when you can have this ductile behavior completely, in the tension and compression region, reinforcement is there, ductile behavior, or if reinforcement is there only in the tension region, ductile behavior? Tell me. Member subjected to impact, when it will be subjected to failure, right? That will result in which one? D. What is the D? Supports of continuous beams, right? Supports of continuous beams means what? What is the meaning of this supports of continuous beams? Whenever they are continuous beams, you are having, right? Continuous beams means what? If you just observe, bending moment will be like this or not? Bending moment diagram, if you just observe, this is how the bending moment diagram is there or not? Then in this case, doubly reinforced will come into picture or not? Then in this case, doubly reinforced will come into picture or not? So D is also correct now. Impact loads are there, also it is suitable, right? Like that, which options are correct now? A, B, C and D are correct, right? First 4 options are correct, right? First 4 options will be correct to consider, right? Like that. So is that clear, all of you now? These are some questions on which one? These are some questions on which one? This MSQ questions on this reinforced concrete structures, you can say. Now, so these are the classes, you can say. Today at which one? Today this is our YouTube class, and again today at 8 p.m. you are having the class on field astronomy. Okay, we are having the field astronomy class. All of you try to attend that surveying part, you can say. We'll be discussing that, right? Today at 8 p.m. and tomorrow at 8 p.m. also we'll be discussing that class. Okay, field astronomy topic will be completed. Again, I'm telling you that there is a price hike alert. If anybody is willing to subscribe for the plus courses, subscribe as early as possible. So if you are having any doubts regarding the subscription, you can use my code. You can call me at this number and I will be explaining you. And you can use this code RP Civil for subscription. Then you will be getting the discount, you can say, right? Like that. Now, price hike, you inform all your friends, juniors, and even if you are willing to subscribe as early as possible. So this is your faculty team and this is my contact number. You can contact me at this number regarding your doubts of subscription and any subject doubts also. Okay, these are the subjects I'll be taking, all of you know. These are the advantages when you are using the code RP Civil, and you just to follow my profile in Unacademy app at this link, https://unacademy.com/@RP Civil. Okay, so this is my contact number. Thank you, all of you. So the complete course on transport, the complete course on which one? Reinforcement